Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue with logs, guys, but we're going to really hopefully solidify and strengthen your log skills. Hopefully you've seen that logs are nothing to really be scared of, okay? I know I keep repeating myself, and I know I'm a broken record, but there's a reason for my insanity, and it's because I want to make sure you understand really how logs work. If you understand the base of logs, everything else is that much easier to understand. Please remember, brothers and sisters out there in the internet world, that the log base b of the answer x equals the exponent. So that translates into the exponential base b to the y power equals x. Believe it or not, if you get that, that's pretty much half the battle. Okay? It's the students that don't get that that really, really have a hard time. Now, we're going to talk about some properties of logs. And if you think about logs, we know that logs and exponents are inverses of each other. So I'm going to ask you a couple questions and hopefully you'll understand how they all relate to each other, guys. If I'm multiplying the same base, what do I do to the exponents? You add them, right? Okay. Well, check it out, guys. Remember that everything's inverse, right? In this case, I have log base b of mn. Log base b of m times n. There's a multiplication here, right? Now, before, when you multiply the same base, you keep the base and add the exponents, correct? Well, in this case, everything is switched. So you're keeping the base, but you're adding the answers. So what's happening is log of b of m times n splits up, expands into log of m plus log base b of n. So just like in exponents, when you multiply the same base, you add the exponents. Here, when you're multiplying two values with the same base, you can add those individual logs, my brothers. For example, log base 3 of 5 plus log base 3 of 4 can condense into log base 3 of 20. Okay? This is the condensed version or contracted version. This is condensed. Condensed. And this is expanded. You have to know how to toggle between both. You have to, my brothers. Yes, sir.
How would you know if it wasn't log base of 3, 10 plus log base of 3, 2 instead of log base of
Okay. In this particular case, I gave you the 5 and the 4. Now, if I wanted to, and I tell you expand this, you don't know that it's 5 and 4, right? But you could break it down to its primes. You could go log. This really isn't totally expanded all the way because of that. So 20, if you really wanted to expand that properly, it'd be log base 3 of 2 plus log base 3 of 2, right? Plus log base 3 of 5. And then even this guy, I can expand it a different way because that's 2 squared. So I could go 2 log base 3 of 2 plus log base 3 of 5. But I haven't shown you that one yet. But I just want you to understand it's always going to be the same when you not condense it, but when you expand it. You just break it up into all its possible factors, my brother.
If you square log, why did you write the 2 in front of the log?
I'm going to show you that now. It's a property. It's a good question. He asked, why did I, when I had the answer squared, why did I pull the 2 to the front? You'll see now in a second, y'all. My brothers, what happens when you divide the same base? You subtract the exponents and keep the same base. So in this particular case, I have log base b of an answer divided by an answer of m over n. So when I have a division, that expands into subtraction. You should be saying to yourself now, oh, wait a second. Moro's right. This is the same thing as exponents, just a different way. It's just the inverse. So, for example, log base 4 of 48 minus log base 4 of 12 gives me the log base 4 of 48 over 12, which equals the log base 4 of 4, which equals 1. Because log base 4 of 4 equals 1. Yes, sir, my brother. Okay, sorry. Thank you, sir. I spelled condensed wrong. I apologize. I should have paid attention. Go. All right. So guys, remember, log of the same base times the answer that is equal to the base. They cancel out. It's going to be 1, my brothers. Now, this is the one that my boy was asking about. What happens, guys, when I raise a power to the power? Do you remember that? If I go x, very good, my man. It's equal to x to the n times m. Very good. You multiply the exponents. Thank you. And you keep the base. So when I have log base b of m to the n power, I can expand it by bringing this exponent literally to the front. So now it becomes n times the log base b of m. Remember, when I raise a power to a power, I multiply. So I'm multiplying that exponent to the whole entire log. Okay? So for example, 8 log base 3 of 2 equals what? Well, this can be contracted to log base 3 of 2 to the 8th power. Very good. Very good, gentlemen. Does that make sense? All right? Now, yes, sir, my brother. No, I put parentheses here in this one here. I'll change the color so you can know. I put parentheses here to really show and illustrate that you're multiplying that exponent to the log, my brother. In this particular case, I took this 8 and I simply put it up to the exponent. Now, if you wanted to go like this, that's fine. But the reason I did it here, again, I'll change colors again, is because I'm taking this exponent, I'm multiplying it to the log, my brother. Does that make sense? Thank you, my man. Yes, sir.
What if the 2 is a 3? Like, how would that work out for the 8?
What if the 2 is a 3? That's a great question. Let's just go ahead and say that this was a 3, okay? Well, this is a 3. Well, this would cancel. What drops down? Just the 8. You actually wouldn't have even had to have done all of that work, to be honest with you. Yes, sir, my brother. If, let's say, this was a 3, this just would have gone boom, and you got the 8. Brilliant question. Thank you so much, sir. Very good question, my man. But again, just for learning's sake, we've got log base 3 of 2 to the 8th power. Excellent. Now, properties of log. The good thing, I went over this already with you guys, but the even better thing is I'm going to be my normal self and I'm going to repeat it. Because I want to make sure that you're learning and that you understand everything. Because this can be very, very simple and easy if you actually know everything. So when I have base A raised to the log of base AX, these guys cancel and I'm left with X. So for example, 3, the base 3, raised to the log base 3 of 7. Oh, the base of the log and the base of the actual value are the same. Bye-bye, equals 7.
So that's kind of like similar to what I asked before, right?
Correct, sir. That's exactly related to what you asked before. Thank you, my brother. I'm really proud of you. If I have log base A times an answer of A to the R power, those cancel out, my brother, as well, and it equals R. So if I have log base 3 of 3 to the 5th, fuagata, and I've got 5 as my answer. Remember, these come from the more simpler properties, which we talked about as well. This is what allows this to work. Remember that we said that log base B of B equals 1. That's why these guys are allowed to work. Remember that I said base B raised to the log of base B equals 1 as well. This is what allows the logs to work, okay? Now, We haven't talked a lot about it, but it's coming soon, and I might as well just tell you right now. Well, actually, I think we'll talk about, we did talk about ln, right? A little bit? It's called a natural log, right? Okay, there's a common log with a base 10, natural log with a base e. I want you to understand that everything we're doing with logs works for ln. I swear. What's the difference? Well, the difference is log is base 10 or other bases. ln is always base e. But I want you to understand that ln of e will equal 1. Why, Moro? Because what is the base of ln? It's an e. So if I have e to the ln power, that also equals 1. Please remember, guys, this I do remember saying, ln is log to the base e. So therefore, if I have log to the base e of e, that equals 1. But since log to the base e is ln, ln of e is 1, and e to the ln is also 1. They will cancel. Everything we've done with logs, I swear, is the same with ln. Okay, my brothers? Except the base of ln is e. Does that make sense? Yes, sir, my brother. Log, okay, hold on. Log base of ln, no, that doesn't make sense. Yeah, but ln is a log of base of e, yes. But what you're asking me is log base ln, that doesn't exist. No, hence why it never exists. Thank you, sir. Thank you, my brother. I appreciate your inquisitiveness, sir. All right, so now, guys, that's literally it. That's my lesson. Woo! Done. Almost. We got a change of base as well, but that's pretty simple. All right, y'all. So let's check this out. All I want to do is write this as a single logarithmic expression. Sometimes they will say contract. Okay? Sometimes they will say condense. Sometimes they'll simply say write as a single logarithm. So we have a subtraction, but subtraction came from division. So this is going to be log base 4. Great job, guys. Of 32 over 2, which is log base 4 of 16, which is log base 4 of 4 squared, which is straight up 2. What? What? That's not a matter of we can do that. It's a matter of you have to if that's the way it worked out, my brother. Since I had log base b of b, they cancel out, my man. You always go all the way to the end. You always simplify. Sometimes it gets real pretty and you simplify really nicely. Sometimes not, my brother. Let's say that would have been a 36, for example, my man. Let's say it would have been a 36 instead of a 2. Then that would have been log base 4 of 36 divided by 2, which is 18. But check this out. Just check this out. This would be log base 4 of 9 plus log base 4 of 2. You with me? Because I'm about to destroy this right now. This is log base 4 of 3 squared. What? Plus log base 4 of 2. Oh, I feel something great coming out now. Ready? Ready? Look at this answer. Look at this. Beautiful. So now I got 2 times the log base 4 of 3 plus log base 4 of 2. What we did here, where we went log base 4 of 4 squared and it canceled and my answer was 2, that was just coincidental because I had the same basis. But in this case, that would be my answer, my brother. This is all the expansion that I could do, sir and sir. No. I went backwards. I went from a single to an expanded. Yeah. Thank you, my brother. God bless you. Good question. Sir, my brother. Thank you, my brother. Yes, sir, my brother. Yes, you're going to have to solve equations using this, and it's going to be super simple. I like the attitude. I like the questions. You're going to be fine. Watch. Hey, how about this, guys? This is going to become log base 2 of x to the 6 times y to the 5th. You're done. Remember, we expanded, you need the log in all of those. But when we condense it, when we contract it, it's just one log. Addition condenses back to multiplication. C, I got the log base 4, okay, of 5x times 3x, so that's 15x squared. Done. Literally. 2 log base 4 of 6 minus log base 4 of 9. Go, kick it out. Don't tell me don't. You tell me what you... Well, do it. Okay, you have a question on C. Yes, sir.
Put the exponent of the x in the front.
No, because then I would be expanding it. This is one single logarithm. Remember, you got to know the difference between the expanded and the contracted. So, my brother. All right, who wants D? Come on. I believe. Yeah? No, sir. This is of 6 squared divided by 9, my brother. So this would be log base 4. Hey, good try. Thank you, son. Takes guts to ask. Then that's log base 4 of 4, which equals 1. Thank you, bro. If you don't make mistakes, you would never going to grow. Good job. Proud of you. Does that make sense to everybody, my brothers? Yes? Okay. Let's continue real quick. Now I want to expand it. Okay. So this is going to be, remember, this is a multiplication with a division. So this is log of 4 plus log of x minus log of y. Do you see how come I did that? Yes, sir.
Oh, you get the 4x
Because 4x, 4 times x is 4x, so I got to split that up into the 4, the x, and then I'm dividing it all by y, so minus y. Yes, and actually, should it be like this?
Yes, I was going to say that.
Should be in parentheses because y is being subtracted to the whole entire product.
Because if not, it would only be divided
To the x. Very good job, my brother. Good job. Yes, sir? No, buddy. This is not 4x. This is 4 times x. Log of 4 plus log of x. You can have log of 4x, but it's not expanded. For this bad boy, I've got log base 3 of 3 squared, because that's what 9 is, plus log base 3 of x to the 5th. All right. Let me see how much I have left here. Okay. I'll make a deal with you. If you guys can tell me this one correctly, I'll stop here. We'll continue and finish up tomorrow and do the homework together tomorrow. I need this the right way. Wrong answer, though, and we got to do it on your own. Do it, my brother.
All right. So for the first one,
Sir, you got it or you don't got it? Okay, this is my last chance, guys. If he doesn't have it, we're done.
2 log 3 is 3 plus 5 log 3 is the base x.
2 log base 3 of 3 plus 5 log base 3 of x. Clean it up.
2 plus
Bam. 2 plus 5 log base 3 of x. All right, guys, I'm a man of my word. Tomorrow we'll finish this up. Homework is technically not valid, but your homework is to make sure you understand everything we've done up to now. God bless you. We'll continue tomorrow. Have a great day. I hope you learned a lot. Bye-bye.